So our next speaker today is Matt Patterson, who works in tech schools, I believe, and using the Donkey Car project in an educational context. So I'll be really interested to see how this is used by other people as well. Thank you, Matt.
All right, thanks, John. So this presentation is a story about a journey that I'm currently on to improve the teaching of our students in STEM, or science, technology, engineering and mathematics, which is a sort of big buzzword that people use a lot in education at the moment. So it actually started about 20 years ago when I volunteered at this new computer clubhouse in Fitzroy, helping these disadvantaged students in the nearby housing flats, learning how to use robots and also helping them making computer games in Python. And I just thought, like, the sort of the format, it was all very project-based. There was no, like, lecturing, and I thought, you know, this is a great way to do things. Why don't we do this more in schools? And then I just sort of sat on this idea for a long time, and nothing much happened. And I went, you know, I worked as a software developer, as an engineer, and then I ended up working at Melbourne Uni, making these multiplayer educational computer games. And I sort of caught this bug of, you know, being interested in education again and what's the best way to teach people and etc. And so then I went back and I trained as a teacher and worked at a school for a bit. And then I got a job at these, they've just released these tech schools over the last couple of years. And around the same time as I did this, as I started working at this tech school, which I'll talk about in a minute, I found out about these donkey cars. And to me, this seemed like a great opportunity to teach people in a really hands-on way where you learn by doing rather than necessarily being lectured. It's a new technology. People know about it. It's sort of, yeah, kids are interested in it. It's relatable to students. The students have, you know, opportunity to learn a whole lot of skills, and also it's based on some pretty open and widely used technologies like Raspberry Pi, Python, webcams, and RC cars. I know when I was growing up, I was quite interested in RC cars. So what are tech schools where I'm working? It was established and funded in 2015 by the Victorian government. So it's a government initiative. They've introduced 10 tech schools across Victoria. The school that I work at, the Yarra Ranges Tech School, was the first one to be operational. It's a model of sort of delivery of STEM skills at a specialised facility. So we don't have our own students. We bring in students from the surrounding area, and they come in for specialised activities. And the schools and students get access to facilitators with experience working in industry and STEM fields. So where I work, the Yarra Ranges Tech School, we have 20 feeder schools that all come and send their students to us. And the students visit for like day-long excursions, but they usually come, you know, 3 or 4 times per year. So you do get to know the kids over time, and then they'll come back again the next year and the next year. They do one activity or design brief per visit. And each challenge will usually focus on, you know, 1 or 2 technologies like, you know, Arduino or Little Bits or some kind of robotics or virtual reality. Yeah, and so we try to deliver this sort of STEM education in an engaging way. So this, around the time that I started at the tech school, I went to this little conference, and this is what I was. So this was like the executive director of 2 of the tech schools. He was like a senior person in the Department of Education. And so that was his perspective. And I'd just been working in a school as like a science and maths teacher, so I could understand a little bit. I think especially around the years that we're targeting, which is year 8 to year 10, there is often a lot of disengagement in schools at the moment. So I don't know if any of you have had teachers like this. I can see if you... Oh, what's going on here? Kind of lost it. I want to play this. Ah. There's no sound. I'll just be a second. Pardon? It's not my computer. But... Oh, maybe is it in there? We might have to just go with that if we can't find it. All right. Anyway, you get the idea. Pardon? No. Look, can one of you guys? You guys probably know it. Anyone? Yeah, that's one. Anyone? Anyway. Yeah, it's just kind of funny. So this is sort of how not to teach STEM, but unfortunately it is sometimes the way it's taught. And this is sometimes how the kids look in the class. All right, so how should we teach STEM? So I think, and there's like developing experience and evidence that we want to encourage students' problem-solving skills and their design thinking. So the way that they, not just like solve a maths problem, but actually design a solution. It often helps with engagement if there's some kind of real-world context of what they're doing. And rather than having like what we saw on the last slide, like just different silos. Like there's a science class where you learn science, and a maths class you learn maths. And if you're lucky, there's an IT class. Really drawing everything together and not having these artificial boundaries. And it's more just about solving some kind of project. And project or design based. So this is the way we try to do everything at the tech school. How to engage students? Just some things that we've found. I don't know if any of this is scientific. It's more like things that we've found. The more hands-on an activity is, the better, especially for a lot of, year 8, year 9 boys. Some kind of real problem that they're solving, some kind of something that students can relate to, and something that like the difficulty that it's challenging to students, but it's not too challenging. So we often throw kids right in the deep end, like programming Arduino in Arduino C or Python, SSHing into Raspberry Pis and things like that. And so that could overwhelm the students, but the way we do it is we start them off with very step-by-step instructions so that they can develop their confidence, and then once they've developed their confidence, then they're free to sort of go off and do things in their own way. And then also, we just seem to find that if there's some kind of game element, then that takes kids to a bit of a higher level of enthusiasm. And so this is one of the games that we've created. It's like a sort of old school retro with the retro music and whatever. While they're heating up, they're making these energy efficient houses, and they're waiting for a few minutes for the houses to heat up. And while they're waiting, they've got all this music playing, and they're part of a game. Some of the activities we do, I'll just go through a couple. So there's one with wearable electronics, where by the end of it they have their electronics, which is like little bits, an Arduino sort of attached to their bodies and their when they demonstrate them. Robots navigating a maze. This one is actually a little bit similar to Donkey Car, but a lot simpler. We've got these dog robots and humanoid robots. They sort of stand on their head and do flips and all sorts of things. And we have some Raspberry Pi and Python activities like this. Students create a voice-activated chatbot, like in a supermarket, and they do farm monitoring. All right, so I'll just quickly talk about this Ringo Arduino programming activity. This is one that I've spent quite a lot of time working on and delivered a lot of classes in. And it's basically this little robot going around a maze. And it starts off with a small maze, and then when they get it through that, a bigger maze. And then finally, we have a maze going across the whole room. And we turn off the lights, and they've got lights flashing on their robots, and they do some racing. And the kids seem to really, it's just very simple activity, but the kids seem to really like it. And so if we look at what we're going to do with donkey cars, it's probably going to start off being quite similar to this Ringo robots. So, we're going to assemble a car compared to just connecting the robot. We're going to name you're going to name your car. That's what we often get kids to do. Then they get a sense of ownership. Going to do calibration, do some graphing of the calibration values, drive around the track versus programming the robot to navigate through the maze, and training the car to follow the lines. And then we're also thinking about some kind of like lights or sounds or something that we can add on to the Raspberry Pi, just so that some kids want to race and some kids just want to make their car look cool. And so we want to try and have these multiple entry points that people with different interests can do the same activity in a different way and both enjoy it. That's just looking at some of the skills that they're learning while they're sort of having fun. All right, so that's like the first activity that we're hoping to do with the students. And by the way, if you can think about any ideas that you have, we still haven't finalised what we're going to do. So I'm very much interested at the end to hear your feedback. So the next thing is we want to get kids to start thinking about logistics and supply chains and moving. I think these are some good skills for kids in about year 10 to be thinking about. So I'll just. Oh no, I can't do this because there's no sound. That's okay. I'll just play a little bit. So everyone knows that when you buy something from Amazon, a lot of the warehouses are actually all managed by robots. And so people don't, I think a lot of changes are going on in our world and people don't actually realise it. And so when you buy something from Amazon, you don't realise that it's all being moved around in the warehouses by these cool little robot things. So what we want to do is create some kind of logistics activity. So this would be for people who've already done the introductory activity. And what we're going to do is, I don't know if you'll be able to see this, get the students so imagine they've got a car with like a box on top, and then we want to put an ultrasonic sensor that detects whether there's anything in the box. And then when you go and put something into the box at the loading point, then it will recognize it and it'll automatically transport that to the delivery point, and then you can unload it, and then at the delivery point it'll get unloaded, and then it would either go back empty or it would be loaded up with something else. And the idea is, and so the activity could be something like robots moving around hospital supplies in a hospital, something like Amazon deliveries or your Uber Eats, or there's all sorts of possibilities. But what we'd really like is for the students to be able to form sort of big teams, so like one team at one end of the supply chain, one team at the other end, and then they're working together and competing against other teams to see how much product they can transport. Yeah? No. So the way it generally works at the tech school, because we have 5,000 or 6,000 students come, we can't really afford to give every one of those kids one of those cars. So they just use it for the day, and then we'd sort of take it apart again in the next, yeah. That's that. Other activities, and again, we're just still thinking about what we'd like to do. I think there's quite a few opportunities. One would be some kind of systems design challenge where you sort of add or modify features to the car. Another would be, this is like the ideal sort of thing that I think would be pretty cool, but not sure if it'll ever happen. Some kind of industrial automation challenge. We also want to get these robot arms and conveyor belts. And if there was some way to combine together the donkey cars driving back and forward and some robot arms picking things and putting them in the box or whatever, then that's sort of like an aspiration. And there's some quite interesting robot arms that are coming out these days that are quite becoming a lot more affordable. Now, where did my thing go? Not sure. Pardon? I can just restart it maybe. Yeah. I can just start it up again. Yeah, I'll just do it again. Cool. No. So I'll stop that. Sorry guys, I'm not sure what happened there. All right. So why do we care about creating these sort of real-world hands-on activities for students? Why do we care? I think the thing is that today technology affects every field, so it affects every person in our society. They're all going to grow up over the next, these students are going to grow up over the next 50 years using technology every day. Pardon? Oh, computer graphics. Yeah. Yeah. So that is, yeah. Yeah. And so a lot of this stuff is relevant. This is just a small sampling of things like Amazon. Amazon's got their own deep racer, by the way, which is very similar to Donkey Car. So they're getting involved in this. Uber and Lyft, they're obviously working on their own self-driving Ubers. And Google and Waymo and Tesla are all working on self-driving cars. And I think this sort of self-driving technology is also very useful for logistics and truck driving and things like that. Yep, all right, cool. So that's basically it. It's basically the reason why we should, one of the reasons why we should learn about these sort of activities is that it's relevant for everyone, but for some people who might be interested in following some sort of computing career, there is actually some potential financial benefits and benefits to society from people doing that. And when we talk about the STEM problem that people are talking about, we need people learning more about STEM. A lot of it is actually in computer science. So a large proportion of these STEM jobs that people talk about are all in computing, whereas only 8% of STEM graduates are actually currently studying computer science. And parents want their kids to learn about computer science, even though the high schools don't teach it. Computer science courses at high school are actually some of the most popular courses. And in terms of diversity issues, where currently we have very few, there's a lot of stuff in the news about Google and Yahoo and some of these companies not having many women in their workforce. And we can actually start to solve these issues in the school because women who try computer science in high school are 10 times more likely to major it in college, and people from minority backgrounds are 7 times more likely. Anyway, as we saw before. So should we just go to break now? Is there? Anyone?
Thank you very much, Matt.